So we're going to be talking about the rules of exponents. So we have a lot of different rules that we want to go over, so I'm going to write down all the rules right now, and then we're going to do examples that cover all the rules individually, and then the hardest part, putting it all together. So let's talk about the rules. The first rule, I'm going to give them each number so I can refer to them later. So rule number 1 is going to be the product rule. The product rule says that anytime you multiply two exponents together that have the same base, you end up with another exponent which is the sum of the powers. A to the m times a to the n equals a to the m plus n. Okay, second rule. This one we call the basic power rule. Now, depending on the book you use or the software you use, these rules might have different names. So the rules names aren't as important. You just know them as, just know how to use the rules. That's the important thing. So the second rule, the basic power rule, says anytime that you have a power and you raise it to another power, you end up with the product of the two powers. A to the m times n. Rule 3. We have the power of a product. Power of a product. Anytime that you have a product raised to the power, what you do is you raise each term or each variable to that same power. You can think of it as distributing the power. Okay, rule 4. I'll make this one a little bit more spaced out here. It's going to be the power rule for a quotient. The power rule for a quotient says that if you take a quotient and you raise it to a power, you end up with the power applied to the top over the power applied to the bottom. Rule 5, we have the quotient rule. Now, this is an analog to rule number 1. Rule number 1 says that if you multiply powers, you end up adding the exponents. Well, the quotient rule says that if you divide the powers, then you actually subtract the exponents. Notice, by the way, that it's top minus bottom. That's very important. You'll see why a little bit later. Okay, next rule. We're going to talk about negative exponents now. So all of the below rules are useful for negative exponents. So first, rule number 6 says, anytime you raise something to a negative power, that's equal to 1 over that exact same base, but to the positive power. Okay, next one. This one is useful when you have negative powers of different variables, some on the top and some on the bottom. The rule tells us that the powers move to the other side. Notice that the negative m went to the bottom of the next fraction and the negative n went to the top as positive n. In other words, things with negative powers switch to the other side. Next one. What if we have a fraction to a negative power? This is a nice little shortcut that I recommend using whenever you have a fraction to a negative power, although you don't need to use this. However, it does make your life a little bit easier. We end up with the reciprocal of the fraction, and the power gets swapped to the negative one. sorry, to the positive 1. Okay. Last rule that we have, this is going to be for raising things to the 0 power. Sometimes we call it the 0 exponent rule, although it's not really a rule, it's actually a definition. So the 0 exponent rule says that anything to the 0 power is 1. That's actually as long as the base is not 0, but you're never going to see 0 to the 0, at least not till more advanced math classes. So this is all the rules, and we're going to focus now on using the rules. First, let's do simple problems. I don't mean simple like they're easy. I mean simple in that they're not complex. They're not going to use all of the rules at once. We're going to do problems towards the end, examples where we actually use most, if not all, of the rules. So those are going to be very challenging. Let's practice using each rule though one by one, just to get used to it. So, problem 1. Actually, the example for all of these is going to say simplify. Okay. So, we have d times d to the 7th times d to the 4th. So looking at these rules, we notice that rule 1 will help us here. So by rule 1, and I'm going to put a little 1 up there to show us that we're using rule 1 for this, we actually add the powers together. We end up with 1 plus 7 plus 4, because the first term actually is to the first power. This becomes d to the 12th. Next one. Again, we're simplifying. M squared to the 5th power. So looking at the rules, we notice this is an application of the basic power rule, rule number 2. So by rule 2, this says that I actually multiply the powers together, which gives us m to the 10th power. So let me actually write this down so I don't have to keep writing simplify. So for all problems, simplify. Next one, problem 3. 2 times 8mn squared. This problem is a little bit harder than the others because we have to make a decision. Do we multiply the 2 times the 8mn first, or do we deal with that power first? Well, let's recall our order of operations. Exponents come first, and then we multiply. Okay? Exponents, and then we multiply by the order of operations. So we have to deal with this power first, and then we can multiply that 2 that's in front. So what rule do I use to raise this product right here to the power of 2? Well, we have the power rule for a product. Power of a product. That's rule number 3. So by rule number 3, the 2 stays put, but each of these gets squared, which ends up being 2 times 64m squared n squared. Now we multiply the 2 in front, and that just gets multiplied by the 64. We end up with 128 m squared n squared. And that's it. That was a 2-step problem, although we did only use one of the rules, the exponent rules that we have. Alright, let's do another one. X over 6 squared. X over 6 squared. Well, this is the power of a quotient. We look, and that's actually rule number 4. By rule 4, this is just x squared over 6 squared, which is just x squared over 36. All right, let's keep going here. Doing well so far. Next one is y to the 9th over y to the 5th. So we notice that this is a quotient. So by the quotient rule, we know that we subtract top power minus bottom power. So 9 minus 5 is 4. So it's y to the 4th power. Next one. I know these are all pretty basic so far, but we're just getting used to these here. So we're going to do z to the negative 8th power. So by using the negative exponent rule, this would be rule number 6. We end up with 1 over z to the 8th. Now, you might be asking, how do I know if I want the form z to the negative 8th or 1 over z to the 8th? Aren't they both okay? So one rule I should write down for you guys is when simplifying, never leave negative exponents in your answer. Oops, forgot to box this here. So this is really important. We are not allowed to leave negative exponents in your answer. So that's what rules 6, 7, and 8 are for. They are all designed to change from negative to positive exponents. Okay, let's keep going here. X to the negative 11th over y to the negative 8th. So in this problem, we have x to the negative 11th, y to the negative 8th. They're both negative powers, so we have to move them to the other side and make them positive. That's what rule 7 is for. So by rule 7, this becomes y to the 8th, and on the bottom we get x to the 11th. And that's it. Next one, I'd like for us to practice using negative powers a little bit in a more basic way. Actually, first let me, we talked about raising z to the negative 8th. Let's deal with a number. So what would 3 to the negative 2 be? So again, by rule 6, we know that this is 1 over 3 squared, which is 1/9. It's not so bad. What about negative 3 to the negative 2? This can be very confusing because we're raising a negative number to a negative power. But let's look at the rule closely. Rule 6 says that we write it as 1 over whatever I had before squared. The base has to stay the same. The base does not change in the rule, only the exponent does. So this becomes 1/9 again, only because negative 3 squared is actually 9. Okay. Alright, let's do another one. This time let's deal with some zero powers here. Okay. So we are on number 10. What would 3 to the 0 power be? Well, we know by rule 9, this is actually the negative exponent rule, that's just 1. Because anything to the 0 power is 1. Okay. What about negative 3 to the 0 power? Well, anything to the 0 power is 1. So by rule 9, this is just 1. Let's look at the following one. Now this is a tricky one It looks very similar to the one before, doesn't it? It's very different though. The negative is not attached to the 3. Rather, what this actually means is take 3 to the 0 first and then make it negative. The way you can remember this is whenever you see a negative with a 0 or with a power at all, that's actually -1 times the power. We could have also written it like this. That's the same thing. No matter how you write it though, the fact remains you have to do the exponent first. So 3 to the 0 is 1. So in fact, we end up with -1 times 1, which is just -1. Okay. So we've practiced using pretty much all of the rules. It's time now for us to do some more advanced problems. Okay, so let's write that down here. And just as a tip, always use the order of operations when doing multi-step problems. So order of operations are what's going to help you actually do multi-step problems. They still apply. Let's write down the order of operations. To remember, we have the parentheses, we have exponents, we have multiplying and dividing, we have addition and subtraction as a group. Now, we don't really have addition or subtraction in any of these problems. So in fact, we don't have to worry about these. We do have to worry about the rest of these. Let's do our first problem. I'm going to write down every single step that we do, okay? Our first one, 4h to the -3rd power squared times 2h cubed. So by order of operations, I have to deal with exponents first. Be careful here, because even though we have parentheses, all the parentheses are doing is separating and grouping here. There's nothing actually happening inside the parentheses. So I'm going to go ahead and square everything on the inside. So I start with, this becomes 4 squared, h to the -3 squared. And the second one becomes 2 cubed, h cubed. All I did here was I used what rule? Let's look back at our rule book here. We actually used the power of a product here. We used it twice, didn't we? So that's rule number 3. But now let's actually raise these to the powers. We have 16 here. We have h to the -3 squared. For that, we're going to use rule 2, which is the basic power rule. We multiply the powers. We have h to the -6th. And then our second term, 2 cubed is 8, and then we have h cubed. Now in this problem, we're actually multiplying a term times a term. We can actually regroup this though. And by the way, before I do that, let me write down what rule I just used. Okay, we used the basic power rule here. That was rule 2. By the associative property, I can go ahead and write it like this. Just so we have the numbers next to each other that are compatible. So 16 times 8, if we were to figure that out, we get 128. So 128. And what do we do with h to the -6 times h cubed? We look at rule 1. That's the product rule. We add the powers together. We end up with h to the -6 plus 3, which is h to the negative third power. Now we're almost done, but we can't leave our answer like that. We have to deal with the negative power. So for this, we're going to use rule number 6. It says that we move the negative power to the other side. We end up with 128 times 1 over h cubed. Okay, that's by rule number 8. But that's the same as 128 over h cubed. So that's it. We used rule 1, rule 2, rule 3, and rule 8. So 4 rules. Four rules used. I just want to write that down so we know it was 4. All right, let's try the next one, number 14. This is going to be a harder one. We have 5 m to the 4th n to the 8th over m squared n cubed, all cubed. Now, there are many ways of doing this problem. What I'm going to do is the parentheses first, though. In other words, I have this 5m to the 4th n to the 8th, and I'm dividing it by m squared n cubed. To do this, I can actually use the quotient rule to simplify. So by the quotient rule, m to the 4th over m squared, I just subtract the powers. Notice I'm putting the answer on the top, just like the rule says. Next we have the n's. We have n to the 8 minus 3. This whole thing is still cubed. I'm not doing anything with this power out here. This power out here still stays the same. So all I've done here is use the quotient rule. So this is rule number 5. Let me go ahead and simplify this. This is m squared. This is n to the 5th. I'm still cubing this. So this is equal to what? Well, we have a product, and it's being cubed. That would be the power of a product. So we raise each term to the power. What rule did we use here? Power of a product, this is rule 3. Next, 5 cubed is 125. What's m squared cubed? Well, this is rule 2, isn't it? The basic power rule. So rule 2. This becomes m to the 5th. Oops, sorry, 6th. We are multiplying here. M to the 6th. And then n to the 15th. And in fact, we are done. So that was not as bad as I let on. So this was 3 rules used. Okay, let's do another one. We have z to the 9th times z to the negative 6th divided by z to the 4th. So what do I do here? Well, first of all, notice that the top powers add because we have a product there. That's the product rule. The bases are the same. We end up with z to the 9 plus negative 6. On the bottom we still have z to the 4th. All we did is we used rule 1 for this. We end up with z to the 3rd over z to the 4th. Next, we use the quotient rule. We know this is equal to z to the 3 minus 4th. And again, quotient rule, so that's rule 5. This gives us z to the negative 1. Finally, by rule 6, I know this is equal to 1 over z. Remember, I can't have a negative power as my final answer. Next problem. This is going to be a tough one. So I want us to start this on a new page. Okay. So this is number, let's see, we left off on 15, so this is number 16. We have 21 p to the negative 7 q to the third over 28 p to the eighth q to the negative fourth all to the negative second power. Tough problem, and there are so many ways we can approach this problem. Personally, I like to deal with the parentheses first and simplify the inside before applying the power on the outside. So simplify the inside first. Let's try to do that. First, 21 and 28, if I divide by 7, I get 3 and 4. So starting off, we have a 3 on top and a 4 on the bottom. Next, I notice the p's. I can use the quotient rule and just subtract top minus bottom. Let's be really careful. Top minus bottom. Next one, we're going to do top minus bottom again for the q's. However, I always see students make mistakes here. Don't forget what happens when you take a positive and you subtract a negative. 3 minus negative 4. Yes, that's right. It's going to actually become addition. Let's see what we get. We actually end up with p to the negative 15th, right? Negative 7 minus 8. And then q to the power of 3 plus 4 is 7. All that to the negative second power. By the way, the only rule that I actually used here was the quotient rule for the first part. And that's basically it so far. Now what? Well, I could write the inside like this and move the power to the other side. Notice I've moved p to the 15th to the bottom. That's all I've done here. What rule is this? Well, you could call it rule number 6. You could also call it rule 7, depending on how you look at it. Why don't I just call it rule 7, since I have not done that yet? Rule 7 basically says you can move negative powers to the other side. Now what? Well, now I'm going to deal with that power on the outside, since the inside is fully simplified. So, we have a quotient or a fraction to a negative power. That's exactly rule number 8. So by rule 8, I flip the fraction and it's now raised to the positive power. Flip the fraction and it's now raised to the positive power. What do I get? Well, according to the power rule for a quotient, I just raise each term to the power. This becomes p to the 15th squared over 3q to the 7th squared. What rule did I use here? I used the power rule for a quotient, so this is rule 4. Next, I apply the power to a power for the top. So I get p. Let me actually not do that yet, because I want to simplify the bottom first. So this becomes 3 squared and then q to the 7th squared. Now what rule did I use to distribute that? I used the power for a product. That's rule 3. Let's go ahead and simplify. We end up with p to the 30th on top. On the bottom I have 9, and then q to the 14th. Where did I get that from? Well, I multiplied the powers together because that's the basic power rule, isn't it? That's rule number 2. So that's my answer. Now I know a lot of you might think I wrote too much, right? Because look at rule, going from here to here, for example, many students don't go from there to there, they just skip straight from there to there. That's totally okay. I'm only doing this to show you guys how we're actually using all of the rules here. Once you get better at this, you can actually skip rules and go a little bit faster, which I highly recommend once you get used to it and you're comfortable. Let's count the rules we use, by the way. We use 1, 2, 3, 4, 5, 6 rules. That is it. I hope that this was helpful, and please do a lot of practice on these problems, as these are very tricky for students mostly because I don't think that they practice using the rules in these challenging ways enough. So do a lot of practice problems, and hopefully this will be okay. I would keep these rules written down next to you while you do the problems, just so you have a reference there, and at least until you memorize them. Thanks very much for watching.